Alright, so I'm going to start by creating a file called helloworld.asm right here. And in the file, I'm going to write two different sections. So we're going to have section.text and section.data. So in our section.text, we're going to have all of our code. In our section.data, we're going to have all of our data. So I'm going to start by filling in data first. So I'm going to put in my message, which I want to put hello world, so I'm going to put my message to be hello world. So I'm going to define bytes and then write hello world with an exclamation point. And then to put in a new line character, we can't just put \n. We have to use the ASCII value, which is 0xa, right? X, like hex A, is our ASCII value for the new line character, and the comma just tells the compiler that we're going to need to concatenate hello world with the new line character. Second and last thing we're going to need in our data is the length of the message. So I'm going to put message length equals, and then right here I'm going to do a subtraction. So I'm going to do $ minus message, right? Now what that does is very simple. So the $ corresponds to the label we're currently working with. So that's going to be message length, right? And under the hood, these labels, they're just memory addresses. So if we do message length minus message, we're literally going to get the number of bytes in message, like the number of characters in here, because each byte is one character. Because once we compile this, message and message length, they're just going to be two blocks of memory that are like literally right next to each other. So if we do this subtraction, we're going to get the number of bytes in message. But for this to work, you got to make sure that message length right here is right under message, right? Or if you wanted to, you could hard code the number of characters. So I don't know, I'd have to count, but if it was 10, you put 10, or you could even put like a hex value like this. But I'm gonna keep this simple and just put $ minus message. Now we're gonna start filling in our code section, so the .text section, and we're actually gonna do two syscalls. So a syscall is just when you tell the kernel to do something. So in this case, the first syscall we're going to do is the write syscall. So write syscall, right? And everything that starts with a semicolon, it's just a comment. So it's going to be ignored when the computer is compiling. So we can actually check right here in this chart and see that the write syscall, you need the number 1 to be in the RAX register. So I'm going to fill that in first. So I'm going to move RAX 1. So I'm going to move the value 1 into RAX. And then right here in the Linux man pages, I can actually check all of the parameters that are needed with this write syscall. So I'm going to put man to write. And right here we can see the C function declaration. And we can see that it takes 3 arguments, right? File descriptor, a buffer, and a count. And in assembly, there's an order for the registers when you're calling functions, right? It's not random. So the first 4 registers, because all of the syscalls we're going to be using in this video, they only take up to 3 parameters. So I'm only going to show you the first 3 registers in priority. So it's going to be RDI, then RSI, then RDX, right? So that's the order. It's RAX, RDI, RSI, RDX. And I'm going to start filling in these registers with the corresponding file descriptor, buffer, and count. So the file descriptor is going to be standard out, and standard out is number 1. Right? If you had a file open with a file descriptor pointing to that file, you could put in that file descriptor and it would actually write to that file. But I want to write it to standard out, which means the console basically. So I'm just going to put 1. And into RSI, we're going to put our buffer, which is basically the bytes we're trying to write. So that's going to be message. And in RDX, the final one, we're going to put count, which is going to be the number of bytes. So it's going to be message length. And then to actually tell the kernel to execute that syscall, we're going to put syscall, because those first 4 instructions, they just populate these 4 registers with these 4 corresponding values. But once we actually execute the syscall instruction, it's going to tell the kernel to execute the right instruction with these 3 arguments. And then the second and final syscall we're going to need to do is the exit syscall to tell the program that we're done what we want to do. We're done executing. So we can go back up to that chart again and Control F exit, and we can see it's syscall 60. So I'm going to go back down. I'm going to move into RAX 60. Sorry, that's RAX, the value 60, because that RAX is the first register in the priority of registers. And then into RDI, we're going to put the exit code. And we can see right here, man to exit. You can see exit only takes 1 argument, which is the exit code. And the exit code is going to be 0 because that means we didn't have a problem executing the program. It's just a convention we use, but you could theoretically put any number in here. And then again, we're going to do the syscall instruction to tell the computer to actually execute that syscall and actually exit the program. And then we're going to need to put 2 more lines of code. The underscore start label right here, which is going to tell the linker this is where we want to start executing. So this move RAX is going to be the first instruction we execute, the move RDI is going to be the second instruction, and so on. And finally, we're going to need to put global underscore start to tell the linker that there is a start label in this file, and that it's going to need to look for it, because if we don't put this global start, it's going to say there's no start label. And it's pretty frustrating because we see it right here, but we have to put this global start at the top to tell the linker there is a start label in this file. Yeah, so that file looks good, and now we're gonna get to the compiling stage. So we can see right here, I only have 1 file. It's this hello-world.asm, and it contains ASCII text. But I'm going to create another file, which is the object file. So I'm going to use nasm to compile our hello-world.asm. So I'm going to specify the format to be elf64 because we're compiling on an x86 64-bit computer. And the file that we want to compile is our hello-world.asm, obviously. And the output file is going to be hello-world.o, right? We want this object file to be named hello-world.o. And then again, if I run the file command, we can see we created a new file called hello-world.o, which is the compiled version of hello-world.asm. So once we've created that compiled file, we need to link that file to create an executable file, which is going to be your actual program. So for that, I'm going to use the linker, so LD, and then hello-world.o, right, to specify that this is the file we want to link. And our output file is going to be hello world. So the name of our executable is going to be hello world. And then once we run that, we can run the file command again and see that we have a third file, which is this 64-bit executable called hello world. And if we run this hello world file, we see our message hello world with a new line. And then we can even see the exit code, which is 0, which is the same number that we put into this exit code. So if I had put value 60 into this exit code, then we would have seen the value 60 right here. Alright, thank you for listening.